So what everybody came here for. Now I'm going to pass it on over to Chris Lampe. He is Chris Lampe of the University of Northern Iowa. The Iowa Waste Reduction Center has over 20 years of experience delivering high effective training using cutting-edge virtual reality technology to educate painters on safer practices, strategies, and techniques that will enable them to use less coating, improve coating finish quality, reduce the environmental impact, reduce costs, and minimize waste. Chris has developed training and certification courses for both military and industry, including several Fortune 500 companies. So without further ado, I'm going to pass it on over to our expert, Chris. The floor is yours.
All right. Thanks, Caleb. Can everybody hear me okay? So,
yes.
Thanks. So as Caleb had said, I'm with the University of Northern Iowa. You see the Iowa Waste Reduction Center logo on there as well as STAR4D. STAR4D is our painter training program within the Iowa Waste Reduction Center. We've been doing painter training for almost 30 years now, as far as working with automotive shops, aerospace, military, wood manufacturers. You pretty much you name it. If you spray liquid coating and some powder, but we developed the painter training programs over the years and research projects based on need. We had companies that came to us that said, hey, we're wasting more coating, solvent, maybe potentially environmental regulations are impacting them. How do we make our business more profitable or to gain environmental compliance in some issues? So a lot of the training and things that we go out and do, we do travel to outside of our borders in Iowa, even though that's where it started and that's where we're housed. And a lot of times we'll give a 1 to 5 day course depending on the number of painters and the need. And a lot of times it's working hands-on, one-on-one in smaller groups or potentially even larger groups, making those individuals aware of environmental regulations, how to reduce their coatings, again, maintain environmental compliance. And so I was asked to give this talk today to give you a quick kind of a snapshot. I can talk about spray equipment in depth more than what we have time for today, but I wanted to give you an overview of each of the type of spray equipments. And then when we go from there, we can hopefully have time at the end for some questions. All right. So Iowa Waste Reduction Center, quickly, is part of the Business Community Services at the University of Northern Iowa. We work with small businesses, typically 100 employees or less. That doesn't mean that we can't work with larger companies on the paint side of things, but if you have environmental regulations here in the state, it could be a smaller body shop or those individuals. You may have 10 to 20 employees that are looking for ways to. Typically, it is to save money, right? I mean, that's the bottom line everybody's looking for. And so what we figured out is if you provide the training for those who are doing the hands-on spraying, best practices, that will enable them then to use less coating, so you can stretch those dollars farther and rework too. If you apply them at the correct thickness, turning down air pressures, fluid pressures, which we'll talk about more later, finish quality really does greatly improve. And then by improved finish quality, you can paint it right the first time. Right, you're not wasting costly money. And over the course of our history, dating back, again, like I said, almost 30 years now, we have collected a lot of data from those who are spraying paint, doing a lot of pre-test or pre-spray data, post-spray data, to find out, what do someone improve, and can you train someone in a short amount of time to get better? The results are yes, you can. The data shows that. However, usually it's follow-on training. Fresher training is one of those big things that sometimes falls through the gap. That definitely is needed, needs to be addressed, whether on a quarterly basis or yearly basis. Businesses have high turnover in some cases where those individuals maybe are doing a good job, or retirement where someone's been in that job for 20 plus years and now they're gone. They're being replaced with inexperienced individuals. So a lot of times we are contacted by those businesses or government institutions that need help. So one of the issues in painting, and I was talked a little bit about, or tasked to talk a little bit about safety, and I'll try to keep it a little bit quicker on this part of it. But as you may know, when you're spraying paint, it's a hazardous material, typically, whether it's the hazards or heavy metals, or what solvents may be present in that coating. So a lot of times those individuals are in an enclosed environment that need to have the proper PPE on. Training, as we'll talk about here shortly, wearing the proper PPE is important. And every class is different that I give, so it could be focused on, safety may not be an issue, but in my experience over the years of doing this, some things are overlooked. So typically each training class will touch on safety in a classroom setting. We do customize our training based on what coatings and equipment that individual is using. So a lot of times it's not a cookie cutter type approach. If I know going in, you're using electrostatic spray equipment, for instance, we'll focus on that in the training course. We use, as Caleb had mentioned, and I'll talk towards the end, 3D virtual reality training. We developed virtual reality training in the mid-2000s. Back then it was 2D, where the technology wasn't quite far enough along to do 3D. But we weren't, as a joke around, we were not gamers. We weren't those individuals who play a lot of video games and programming, but we were paint instructors, the team at the time, and we saw a need to how do you train someone in a classroom setting when you possibly can't go into a spray booth, or it takes time, material, parts. It's very labor intensive to do hands-on training in the spray booth using real coatings and parts, and typically it's fairly costly to do that. So businesses tend not to invest in having us practice on real parts and coating unless it's production parts, which we for sure can do. So virtual reality was one of those things that kind of came about and we developed and kind of got better at as time went by to train those individuals. So if you screw up a part, you're not throwing that part away. You don't have to sand that part out. You can talk to the individual. They're not having to wear a respirator while they're spraying virtual coating, and so you can practice spray techniques that can, in the long run, make that person, he or she, a little bit more efficient at what they're doing. So there are hazards with painting, for sure, right? SDS is one of those things we'll list, whether there's chemical issues, whether there's vapor issues. I see a lot of times individuals not wearing proper gloves, for instance, thinking it's a waterborne coating, there's no danger, no issue there. And maybe that may be slightly true, but they may use solvents to clean parts, which again can affect them, their health. Usually it's these little things over time that add up that makes a person sick. I've been around long enough where I've seen a lot of facilities typically are doing the right thing, but every once in a while you'll run into an issue where you can see a fire danger, which a lot of paint shops, I think, fail to recognize sometimes, where you're spraying, in most cases, hazardous materials and also flammable materials then that are present on the booth floor paper, maybe the walls, the filters, and for sure can be a fire danger. We've had facilities where their paint booth filters have caught fire in some instances. So it's one of those things where a safety data sheet is going to tell you what PPE, what chemicals, what solvents are present that are in there in a paint facility. And then also, one thing a lot of places don't think about is then if you're sanding or prepping parts, if you're sanding over those coatings, that dust particulate that gets up there, is that coating as itself, as it sits, may be a non-hazardous product while it's dry, but once you start sanding those particles and getting them up in the air, or you're spraying them out of a spray gun, those particles are airborne. Now they can become a real issue. So as I mentioned, PPE is one of those things, personal protective equipment, when you're in the spray booth. For sure, whenever a coating is atomized into a fine mist, which I'm going to talk about shortly on spray equipment, there's that danger that it can be inhaled. So brush touching, rolling it on, much less risk at that point. But whenever you atomize a coating, either using compressed air or hydraulic atomization, you're creating a hazard that's airborne. Not just for you, but if someone would walk into the spray environment, they potentially can put themselves at risk. I've seen that before where someone walks in the spray booth while someone's painting and they start talking to that individual who may be wearing the PPE, but that individual who's not wearing it correctly, then he or she can be exposed. I mentioned flammable materials that are present in the spray booth, noise issues, for sure, slips, trips, falls. I've seen spray booths that are not properly maintained. Overspray builds up on the floor. And you almost get these peaks and valleys on the floor that can, over time, become trip hazards for the individuals. Lighting can be an issue in the booth where he or she can't oftentimes see or navigate those areas. And then transporting contaminants on the clothing. That's one thing that you always want to keep all of your PPE at your facility. You don't want to bring that home to you, whether it's in your vehicle as you drive home or whether that's you change your clothes at home. So if you can, keep all of your PPE and all of your clothes, or if you can shower at facilities, large facilities have locker rooms where you can change out clothes. That's best practices. And I think no one ever wants to do something unsafe, in my experience, but unsafe things seem to happen from time to time. Grounding is one of those things where it's more of an issue with electrostatic spray, where coating static electricity can build up. The parts, like in the picture that you see to the right, that's electrostatic spray process where parts hanging on a conveyor. That conveyor is moving into the spray booth, the painter paints it, and then it exits. The conveyors are typically always grounded properly. The issues come up as when the hooks are grounded to the parts, or if you have multiple hooks. And as the hooks are used time and time again, they get coated naturally with coatings and they become insulated. And then that then creates an issue with arcing that it wants to jump from the hook to the conveyor or bypasses several hooks. And when you have a flammable environment with the overspray on the booth floor, walls, filters, and so forth, you could potentially have a spark that could cause a fire in those issues. Or what typically happens is the painters get shocked. They become insulated from the parts, or the parts become insulated from the conveyor. And that shocking is not enough to kill an individual. It's high voltage, low amperage, so it's not going to necessarily, lead to death. But what it will do is it'll constantly shock that painter, wake them up, and that individual at some point is not going to want to be in that environment, or they're not going to want to, do as good a job as they're constantly getting shocked. And I think hooks, which we can talk a little more later, hooks not being properly maintained and replaced and clean is one big issue. Storage of flammable combustible liquids. Always keep solvents, paints, any type of chemicals in a storage cabinet. Have fire extinguisher close by. You can kind of read through there the ideal storage conditions. A lot of times I'll see coatings, paints being stored in the spray booth or directly outside of the spray booth for shorter periods of time. That may be acceptable, but if you're storing waste solvent in a 5-gallon bucket without the lid, say you were flushing out your spray equipment and you leave that container open, I've seen more times than I can count that container is not properly labeled or it's not properly sealed. And so that could be knocked over, tripped, or you could have an accident just based on cleaning solvents that aren't properly managed at the end of each shift or at the end of each day. So keeping up on things and maintaining things is a good idea. Storing coatings, it says 60 to 80 degrees Fahrenheit is your ideal storage range. Storing coatings when they get below freezing or above 120 degrees is usually degrades the coatings. It causes properties of coatings to settle out. Whether those coating properties are able to go back together when it's brought back up to ambient room temperature, that can be an issue. We've seen issues where improper storage in cold environments and the painter goes to spray the coatings and the viscosity thickness is extremely thick. It makes it very difficult to spray, and it makes it very difficult to atomize that coating when it's outside of its normal thickness or thinness, or what we like to call viscosity range. The paint storage or paint mixing room needs to have proper ventilation. You need to move those fumes, the outgassing, a lot of times of the coating or solvents away from there. The more activity you have and the more coating that's stored in those rooms, if you're lucky enough to have a paint kitchen or a paint mix room, they're wonderful to have. You can keep everything in there. They're fireproof, lockable areas that have spill containment typically built into them, but they're also extremely strong smelling. Solvents definitely are present, outgas, cause issues. Those are some areas that when you walk into those paint kitchens, oftentimes you're smacked in the face with solvent. Wearing your respirator in those areas is definitely a must. Wearing your gloves when you're working with or transferring materials or mixing coatings or whatever it may be doing. Keep drums sealed, labeled, grounded. No metal tools, plastic tools, or brass. You do not want to have a spark or fire ignition source in those areas. Polyurethane paint, so isocyanates. It's one of those things where a lot of companies do use urethanes or polyurethanes. Clear coats, a lot of aerospace materials, but they could also be found in commercial or industrial coatings as well. It's one of the leading causes of occupational asthma. Skin contact with isocyanates may trigger an allergic reaction. That's one thing that I think a lot of people fail to recognize is, well, you know, I'm sort of covered, but maybe I'm wearing a loose-fitting T-shirt, and I think that's good enough, and it's a little bit open at the sleeves. And now when I'm spraying in an enclosed environment, my body's being subjected to these toxins and to these chemicals. And if I'm not properly wearing the PPE, or my paint suit is too loose, even, or maybe I'm wearing my respirator, my PPE correctly, but maybe part of my skin is exposed on my neck, or whatever it may be, those isocyanates build up slowly over time, and eventually the individual becomes sensitized to it, and then he or she has to quit painting. You can either get a rash, skin irritation, or even worse, as we said, the breathing issues or the asthma related. Skin injection hazards. This is present only with airless and air-assisted airless or hydraulic atomization equipment, which I'll mention here shortly. Coating is sprayed at a high velocity. So high fluid pressures, typically fluid pressures 500 psi or greater. At close proximity to the skin, the coating can break the skin, enter your bloodstream. Typically happens blood poisoning, and then worst case scenario would be possible amputation. If you're far enough away when using this spray equipment, say I'm a foot away from the part, someone accidentally sprays me, very unlikely that it'll be injected with that fluid stream or fluid droplets into my body. But if I put my finger up to the tip of the gun or put the gun close to my leg and pull that trigger, I can inject that fluid into my body. These spray guns, air-assisted airless and airless spray guns, have trigger locks on it or safety features, where whenever the individual is spraying and they set the gun down to move parts, you want to treat that as a loaded gun, and you want to keep that trigger lock engaged, so to speak, so you don't run the risk of injecting yourself or someone else with paint. So now we can sort of talk about efficiency and why it matters. Transfer efficiency, or TE, as I may refer to it later today, is the amount of coating sprayed compared to the actual amount of coating deposited on the part. So, you know, what coating overspray leaves my gun that lands on the part? Does it hit the target as intended, or does it miss the target? Well, when you use, no matter what type of spray gun, you're going to lose some paint. You're going to lose paint coating droplets either from over-atomizing, high velocity of the droplets with high air pressure potentially will cause that droplet in some cases to bounce off the part. The angle of the spray gun to the part typically needs to be more straight on it is, and the more you angle or the pitch of the spray gun, the tilt of the spray gun from the part can cause those coating droplets to bounce or not stick or land on the part. This affects your efficiency. The type of spray equipment can make a difference. I'll talk about that here in a second. Coating viscosity, the thickness or thinness of the paint definitely can impact whether you're going to be slightly more efficient or not. Some thin coatings, lower viscosity coatings, are easily atomized, and I've seen individuals use higher air pressures than needed, and it speeds up that thinner coating a little bit quicker than what it should instead of a softer spray. And the velocity of that paint droplet has a tendency then to bounce or miss the target. Production requirements. Sometimes you have to get things done quickly, right? So as maybe you're on a conveyor line where parts are moving, and the faster the line speed is moving, the less amount of time that individual has to paint that part. Sometimes they may feel rushed, or maybe they haven't been painting as long a period of time, or prone to spray off the part. Part geometry, the complexity of the part. For sure, if you're spraying flat square panels, your efficiency may be a lot higher than spraying something that's small and more complex with a lot of inside angles, protrusions, and whatnot. And then I always like to say it really doesn't matter what type of spray gun you're using. It really comes down to the operator who's setting it up. Does he or she know how to set it up, what distance they're at, what pressures they're at, what techniques he or she is using to spray those parts can greatly or really has the greatest impact to the equipment. You can have an operation that's maybe not using the best equipment or worn out equipment, and for sure that, or the wrong equipment, and that for sure can impact your efficiency. But if you have an individual who's not properly trained, for sure that person can waste a lot of coating than someone who is properly trained. So atomization, there's two methods of breaking up the coating. We're going to talk about air atomization first, then we'll talk about hydraulic atomization. But basically, it's atomizing the coating using compressed air to break up a liquid coating into fine droplets. And the finer the droplets, usually the finer the finish or smoother the finish. The bigger the droplets, the more rough texture, that an orange peel texture that can be present. So we always tell an individual, you really want to set your spray equipment up based on the viscosity, the thickness or thinness of your coating or your paint that you're using. So everyone has different requirements for finish quality. Customers may have different requirements for finish quality. There may be requirements on film thickness as well, or it may strictly be a finish quality requirement, and you don't care how much paint it takes to get there. Aesthetics are more of an issue, but whatever gun that you're using or your facility is using, you really want to set the spray equipment based on the thickness and thinness of the products, and also film thickness requirements. So that may force you to change your setup of your spray equipment based on, coating A versus coating B versus coating C and so forth. So that's what can make it difficult. Oftentimes you can't just set your spray gun to a certain setting and just leave it there. Oftentimes a really good painter knows how to adjust that gun based on what he or she is seeing in the spray pattern. And also environmental conditions, high humidity, high temperature can impact how the coating reacts, or low temperature, low humidity situations can also impact how that coating is broken up. So for air atomization, when a coating flows through the opening, it says there fluid pressure is less than 100 psi. In most cases, you're going to be at fluid pressures at 10 to 20 psi. So real low fluid pressure. Air pressure is introduced as the fluid stream leaves the spray gun. It breaks it up. So always remember, the higher air pressure you use, the greater degree of atomization, and typically the higher air pressure can also lead to the greatest amount of waste. That's one of the main factors that we've seen over really the 20 plus years that I've been doing this is higher air pressures are going to lead to more waste. So you could set the spray gun up exactly the same and line 10 painters up, and if you adjust air pressure 10 psi between each of those and use the same coating, you can have greatly different results based on that. So it usually, the thing is, it usually doesn't take that much of a jump in air pressure to make a big difference. So you may have an individual running a certain spray gun at 25 to 30 psi. The next individual is running his or hers at 40 psi, and you think that's not that big a difference. But over time, if you spray a few hundred or a few thousand parts a day, it can greatly impact and make potentially a 10 to 15, 20% difference in your efficiency, just based on excessive or high air pressure. So there's different types of spray guns for air atomization. So I'll talk briefly briefly here. In the next few slides, we'll kind of jump into it a little bit more. HVLP uses a high volume of air at a low air pressure. It's not a high volume of fluid. It's not a high volume of air at a high fluid pressure. It's a high volume of air. In HVLP, a lot of places are the requirements for a lot of states, or both state, federal, local regulations may steer you into using as a requirement HVLP. There can be the most efficient spray gun, or one of the most efficient spray guns out there. As we'll talk about, it all depends on how you set it up. Low volume, low pressure spray guns uses a low volume of air. At a lower air pressure, they work really well with low viscosity or thin coatings. They're extremely efficient. Automotive industry, for instance, or potentially the aerospace industry, depending on the coating used. At breaking up that coating stream using a low air pressure, and as I mentioned on the slide before, the lower air pressure you use, typically the more efficient you will be. Compliant is, or reduced pressure, is kind of a hybrid, which was really taking a conventional spray gun and making it HVLP compliant. So a lot of times the air caps were modified to make the guns potentially use less air to break that coating up, and how they were configured. Still uses a little bit higher air pressure than an HVLP by regulation. But again, we're not cranking it up to excessive pressures to get there. But typically, compliant or reduced pressure spray guns are a little bit better at spraying thicker coatings. And then electrostatics. We'll talk more about that, but you charge the coating as it leaves the spray gun. Typically, electrostatics are claimed to be the highest efficiency. They certainly can be. It depends on how they're set up. We'll talk more about that here shortly. So going back to HVLP, you can get a gravity feed HVLP spray gun, you get a pressure feed. You could get a siphon fed, although those have primarily been phased out for the most part. But HVLP is stamped at a maximum allowable air pressure that comes in the gun handle. So look at the picture of the spray gun there with the regulator towards the bottom. It's a regulator there, which is kind of nice to have these where you can watch the air pressure as it comes in the handle. So it's not the air pressure that comes in at the wall, which may be attached to a 30 or 50-foot hose. Whatever's the regulator at the wall, you're going to have much lower air pressure based on the diameter and length of the air hose that leads to the spray gun. So HVLP, by definition, needs to use 10 psi of air pressure or less at the air cap. Now, that doesn't mean you have to get to 10 psi. So it could be 30 psi air pressure at the handle gets me 10 at the cap, and that may work well for the coating I'm using. But in some cases, maybe I can turn that down to 20 psi coming in at the handle, and that gets me, 6 or 7 at the air cap. You lose pressure as it winds through those spray guns, and it makes the bends and turns, and that's the difference for the pressure drop. There's also, as I mentioned, the pressure drop from the wall to the spray equipment. It says there use 3/8 ID air hose or larger. You could use 1/2 inch. I think 3/8 is ideal for most applications. There's always exceptions to that. And then it also says large QDs or quick connects. So what's at the spray gun handle, oftentimes I'll see regular air tools or different maybe sanders or grinders facility or drills or whatnot will use a much smaller fitting at the end of the gun. And what you're really doing is you're choking that gun off. You're starving that gun full of air. And by definition, it needs a high volume of air. And so if you're restricting the airflow that goes into that gun handle, you can, in some cases, choke that gun or starve that gun with air. You typically want to be closer, 4 to 7 inches away from the part. There's no need to be 12 inches or greater. Typically, HVLPs are designed to spray between 1 to 2 feet per second. So your spray gun speed may be a little bit slower than potentially electrostatic or for sure airless or any other type of spray gun. So you want that droplet to go at a slower velocity and hit the part and stick to it without bouncing. So by slowing things down is usually a good idea. Now, if you say, well, hey, what about my finish quality is suffering because of low air pressure, then that comes into equation. You're changing out tip size or the orifice size of the tip and selecting potentially a smaller tip to help break up that coating stream to get better atomization, or if you're not getting enough flow rate through the gun and you feel like you have to crank up the air pressure to get it through that gun. Again, you're limited to only 10 psi at the cap, so you have to be careful with that. But in some cases, you can change out the tip size to a larger size, and that will get you better results. Compliant reduced pressure spray guns, very similar to HVLP and how you would set it up. You're allowed typically to go to a little bit higher air pressure. Typically, it might be 5 psi more or 10 psi more, so nothing dramatic coming out of that spray gun. But based on the configuration of the air cap at the end of the gun, usually it's a smaller orifice size around the fluid nozzle, so it breaks up thicker coatings a little bit better than HVLP guns do. So if you had a slightly thicker coating and I wanted to, and I'm getting poor atomization with my HVLP because I'm limited by air pressure, I would switch to a compliant or reduced pressure spray gun, or at least I would try that. And that would be a quick, easy fix for you to remain in compliance, but also to remain, keep up with production, keep up with finish quality requirements, and then also keep up with environmental regulations at all. They are capable of a little bit higher production rates, 5 to 9 inch standoff distance, so you can be a little bit farther back with these guns. But again, I'm not 10, 12 inches away from there. The closer you are, again, the greater chance you have of being more efficient at what you're doing. Low volume, low pressure spray guns, they're a softer spray. As you see there, it says great for low viscosity coatings. We're still less than 10 psi at the cap. They're rated at 65% efficient or higher. Same thing with HVLP guns. As far as the air hoses, standoff distance. The only time I've really ever seen these guns struggle is when you get a really thick coating to kind of go through them. They kind of struggle a little bit with that. But if you have automotive coatings, aerospace coatings, wood industry, they're very efficient, and it could be a nice choice for somebody who's looking potentially to upgrade from compliant reduced pressure, conventional spray even, and low volume, low pressure could be a nice option and very nice efficient. Okay, so air atomization for fluid delivery for gravity. Now we're just talking about with a cup on top of the gun. It's a cup that's attached to the top of the gun, typically limited to less than a quart of paint. They're lightweight, easy to move around. Almost every shop facility that I've ever visited most commonly has these somewhere, even if they just use them for touch-up. They're present somewhere on your facility, or they may be used for production everyday setting. But they are typically used for smaller jobs. You can tell because they have the quart of paint or less. So if I had to paint, 100 parts, I may not select a gravity-fed spray gun if they're big parts, especially because I have to refill that cup over and over again. You have to keep the cup upright. It has a vent hole in the top, so if you tilt it off to the side, you're going to lose flow rate, and then eventually you're going to lose material and it won't spray. They introduced these plastic, and I wish I would include a picture here, but plastic disposable liners and cups that go on top of the spray gun. They can be very nice to use, very efficient. You're basically mixing and spraying out of one cup, so you replace the aluminum or plastic cup to the top with a bag and liner system, where if you evacuate the air, turn the gun upside down, evacuate the air, you can then spray, in theory, in any direction. So those disposable cups and liners are also a really good, easy thing that you can throw in to get your efficiency up. So pressure feed, you can get low volume, low pressure. I get HVLP, I can get compliant reduced pressure. Pressure feed spray guns, they're either typically fed with a pressure pod, or they could be fed with a diaphragm pump or electronic proportioning system for larger facilities that spray a lot of coating. So you're feeding it through pressure, low pressure, I should say, fluid pressure to the spray gun, like in the picture you see there. But again, we're not talking about high fluid pressures or high air pressures necessarily, but because we can spray or have the ability to have a lot more fluid out the end of the gun, our fluid delivery rate is higher, or ounces per minute is higher with these types of spray guns. Typically, you will use slightly higher air pressure than you would with a gravity fed using the exact same coating. Gravity feds, backing up real quick, was about 5 to 7 ounces per minute on average, depending on the tip. Pressure feed spray guns, depending on how the material is fed to them, could be anywhere between 5 and 20 plus ounces per minute. So much higher rates, much higher fluid. They're used primarily in production settings. So if you have a lot of parts to spray, this is a really good choice to use. They work well. They're pretty easy to maintain. Now, looking at whether you're using a gravity, whether you're using a pressure feed, always look at the droplets. Finer droplets, or small droplets, you get finer finish. Large droplets, you get more coarse texture. And distance matters. So whether you have a gravity fed, a pressure feed, the ones that we've talked about so far, you really want to look at your test patterns before painting. If you look at the ones to the right, both of those patterns do not look good to me. The one on the left is using too high air pressure and it's kind of blowing the pattern out. The one to the right has more coarser droplets, and if I would paint with that, I'd get a very rough textured appearance that may not be desirable. So whether you're using a pressure feed or gravity feed, always look at the paint on a piece of paper or a piece of cardboard before you spray the parts. And then you can also see the distribution of fluid within that pattern, and you want to see it consistent. You want to look a nice, evenly distributed wet pattern. And if you see any inconsistencies, then go ahead and look at the air cap. Maybe you have a horn hole or a hole in the air cap that's plugged, that's not allowing for an even distribution of air to go through the cap. So that could be a maintenance issue that could be fixed relatively quickly. But also look at that droplet size. In some places, requirements, you can get away with a larger droplet size. But if you're spraying a high performance coating or a gloss coating and you have big droplet size, you're going to get a coarse texture. So whether you're using HVLP, low volume, low pressure, or compliant reduced pressure, gravity pressure feed, whatever you're using, always look at your spray patterns before moving on. Okay. So now let's talk about electrostatic. So electrostatic can meet the definition of HVLP, which is a high volume, low pressure, because it's capable of achieving 65% efficiency or higher. Standoff distance with electrostatics is typically farther away, so 8 to 12 inches, or most commonly, depending on the part that you're spraying, if you're spraying more larger pieces of work, you're going to be at 10 or 12 inches away. They are rated, as you see there, 65 to 80%. I know the spray gun manufacturers, whether it be Ransburg or Graco, will definitely tout that. They're capable of that, but it all comes down to who's setting it up. If you set up the equipment incorrectly and use too high air pressure or insufficient flow rate, or spray it at twice the recommended distance, I don't care if you have an electrostatic spray gun that's get 80%, I can get 20%. And I've got plenty of video over the years and plenty of experience watching individuals who use electrostatics use too high air pressure as well. You naturally have to use higher air pressure. There's an alternator in the gun turbine that generates a charge that charges the coating as it leaves the gun. And it has to have a high enough air pressure to turn that in order for you to charge the particles, the paint particles as they leave the gun. And oftentimes the individual will turn those up too high and higher than recommended pressure, and again, that's going to lead to a less efficient process. So as the coating droplets, they're charged as they leave the gun positively charged, they're are negatively charged to a positive grounded workpiece. A lot of times, electrostatics, the wraparound effect is what we're looking for, but the main benefit of electrostatic spray is improved transfer efficiency to the primary surface. So what it does is it fills in the gaps. Okay, so the wraparound, spraying around behind the part is definitely an added benefit, but that's secondary. The real benefit is it fills in the gaps of what you see right in front of you. So because you have, or hopefully because you have a properly grounded workpiece, those coating droplets want to form an even film finish across that surface area. So they want to fill in the gaps, the voids in the metal in most cases. So a lot of times you get a much more consistent film thickness with electrostatics, and then that usually leads to a more or a better finish quality, for sure. The downside of electrostatics is the cost is usually much higher. The cost of these spray guns are a lot of times 10 times the cost of an air spray, of a gravity or a pressure feed spray gun. So the initial cost of the equipment, and then especially grounded conductive air hoses that you have to use, sometimes are a limiting factor. Whether I'm going to use or switch this type of spray gun or not. Everything has to be grounded, as I mentioned. And real quickly, I want to say this on electrostatics. If they're set up correctly, the cost can be justified. And I've seen that time and time again. But simply looking at the literature and saying, okay, I'm going to achieve 80% efficiency by switching to electrostatics is really not true. In a lot of cases, just making that switch and not training the individuals on how to properly clean, maintain, and set up the equipment is a recipe for disaster. A lot of times I've seen tens of thousands of dollars wasted on buying this type of spray equipment and then not providing the proper training on how to use it and maintain it. So if you do switch or do look at going to this type of technology, just make sure you have a training process in place on how to set that up and then, of course, how to maintain it. As I mentioned quickly, hooks, coating builds up on hooks, causes a safety issue. Poor efficiency, so maybe the gun's set up correctly. It's spraying at a high efficiency, but because the parts is insulated from the hooks, so they have too much paint on them, I'm not getting a good wraparound effect, or I'm not even getting a good ground. That can cause issues. Also, make sure everything is, as I said, is grounded, and that's going to give you your best efficiency possible. So now I want to quickly switch to hydraulic atomization. High fluid pressures to break up the coating, so we're not, in this case, using air pressure, we're using fluid pressure to break it up. So oftentimes these are great at breaking up thicker coatings. Although you can use thin coatings. I've seen a lot of wood industry. Their airless is highly used, but I've also seen airless uses for bridgers, water towers, structural steel, that sort of thing. Airless spray tips determine the flow rate, so it takes a special pump. You can't run these guns with a pressure pot. You can run them with a high flow proportioning system that's fed with either piston or diaphragm pumps. that will create the fluid pressure necessary. If you see tails in the presence, you can increase fluid pressure for airless guns. So essentially, they're great at taking a thick coating and breaking it up and getting a lot of material. Or if you have film thickness requirements of a high coating film build, airless is a great choice. For AA or air-assisted airless spray equipment, you get close to working out the tails and good atomization, but then we increase a little bit of air pressure to break up that coating stream, and typically we can get a fine finish and good finish quality. Like I said, they're using the woodworking industry all the time because they're thinner coatings in that case, and you introduce a little bit of air, a little bit of fluid pressure, and you get a really nice efficient spray process. Okay, so now let's switch to coating defects. A heavily contaminated facility is more likely to cause issues. Dirt, debris, that sort of thing. Is that an application issue? You can argue maybe it's not, but any type of dirt, debris that's in a spray booth can enter the wet paint. So poor working conditions or unkept or unclean conditions for sure can cause issues. That sometimes get blamed on the painters, but it can be an issue where you just had a dirty or a insufficient work environment. Cratering or fish eyes, usually it's improper cleaning can be caused it. I've seen individuals who touch the parts without cleaning or not wearing gloves. Touching it with your fingertips in some cases can cause fish eyes or coating defects. Again, it's a contamination. Usually you see it right away on the surface. Runs, sags, that's moving too slow or too close to the part. As I mentioned, you want to be at an optimal distance and you want to get closer to the part, but there is an optimal distance of getting, or an issue where you can get too close to the part. That can then cause coating to build up, more quickly, right? And so reducing the amount of flow rate, if you see a lot of runs and sags, usually that's a case of a painter who's maybe new at the profession, not comfortable spraying. They're more likely to get more runs and sags or have more coating defects. So it's usually spray faster and then watch your distance. Streaking, that's the angle I am away from the part, or I miss my overlap. So you see those inconsistencies, those heavy and light spots that could potentially develop. Typically, we recommend at least a 50% overlap of your spray pattern, up to 75%. A lot of automotive applications now will teach 75% overlap, but you have to have at least a 50% overlap of the wet part of your pattern. If you don't, what ends up happening as the coating dries, you'll see those lines develop, and that's especially true on really big or wide parts. Blistering is an application issue where you're applying too much coating or you're applying it too thick. The painter maybe is moving at too slow a speed, too much fluid pressure, potentially is doing multiple coats without allowing enough flash off time between coats. Waterborne coatings are more tendency to blister, especially under high humidity conditions. So if you start to see blistering, that could be an application that the painter is applying too much coating to the part. Delamination would be an issue where potentially waited too long from one layer of coating to the next, or say I primed these parts and I waited 3 days and then I applied them again, then without prepping the part, sanding or solvent wiping it, that can cause delamination of the coating. Unfortunately, delamination is one of those coating application issues that don't really show up until weeks or months later, or potentially even years later. A holiday or light spot is an area that was missed. So I always say you have to, paint doesn't magically go around corners to fill in those voids. If I can't see it with my eyes when I point the spray gun at it, then did I really paint it? It's like, spraying around the corner. Can I see it? Do I move my body in a position to where I can see what I'm painting? And usually that's what you definitely want to do. So a lot of times just standing still in the spray booth and waving the spray gun and not moving your lower body can lead to a lot of light spots. Dry spray is a dry, rough, grainy texture with no gloss or less gloss. Usually occurs when atomized coating is deposited on the surface, do not melt in. For instance, if I use high air pressure, I'm going to get dry spray. If I use excessive spray distance, I'm going to have more dry spray on my parts. So if you see dry spray, look at the cause of that. Or I could have dry spray on my parts if I paint in one area of the spray booth and coating droplets, miss the parts and have to land someplace. those coating droplets may not melt into the parts that are on the racks next to them. Now, overspray is a little different than dry spray, although overspray can become dry spray. Overspray is any paint that misses its intended target. As I said earlier, you're always going to waste paint. So oftentimes when someone asks what's a good efficiency to be at, it all depends on what you're doing. It truly does. It's not really dependent on the type of spray equipment. It's really how you're setting it up and your spray technique or how you're using it. But if you limit the amount of overspray or spraying time off of the part in distance or time, that will usually lead to a lot more efficient operation. If you see that cloud of overspray that's in the spray booth, none of that coating is going to become productive coating on your part. That potentially can become dry spray as the coating droplets, dry and fall down on potentially parts. But when you see that cloud of overspray in the spray booth, that's all wasted coating. Orange peel will be spraying too close. Sometimes you get a ripple appearance, or as I mentioned earlier, if you have incorrect spray gun setup, that can lead to an orange peel texture. So if you see that, just watch the viscosity of coating or check that, or check to see how much coating is being deposited out the end of the spray gun. And then pinholing is also a coating that's being applied a little bit too thick. Okay, so what is the future? So we developed virtual reality, as I mentioned earlier, almost 20 years ago now, where back in those days it was 2Ds. We've advanced as it's gotten cheaper and easier to use. So you're putting on a headset and you're in a virtual spray environment. The nice thing about it is we can track your film thickness, your wet film thickness, instantaneous. We can check your dry film thickness once you hit the results button. So we don't have to wait for the coating to dry, in other words, to see how much wet paint was sprayed, turned into dry paint. There's no PPE that's required when you're using it, and you can spray multiple parts in a much quicker time frame. So, if I'm to spray, 50 real-world parts, that's going to take time to do that, and there's a ton of value in doing that. However, I can spray 50 virtual parts in about 25% of the time or less because I don't have to set anything up. I'm much more efficient. I can spray a part, I can look at the part, I can evaluate the part, and then we hit paint clear or start over, and all the coating goes away. And I have a brand new part for that person to practice on. We build in lesson plans. You can customize it based on the spray equipment. So if an individual wants an electrostatic spray gun, we can use that. If they want an airless gun, we can use that. Gravity, pressure feed, whatever it may be, you can swap out the different spray guns. In some cases, we can get your actual spray gun, real spray gun, turned into a virtual gun. It's a great training tool for beginners. We can create advanced parts that are really tough to spray. In some cases, we found it's even some complex shaped parts or even tougher to spray virtually than they are in real world. Usually it generates competition while you're doing this because it is a scoring-based system. A lot of times individuals want to get the best score, so to speak, so you can, sometimes that's going to be a healthy competition that can drive someone to do a little bit better. And then you can use it to track painters' performance over time. So there's plenty of memory in the database to generate these PDF reports, and you can track those over time. And oftentimes we'll do that and look back. We have a lot of repeat customers. We can look back to how someone sprayed a part back in 2 to 3 years ago to what they're doing now, and hopefully they're doing a better job today than they were several years ago when we first trained them. We can flip the paint over to what we call accumulation thickness, so you can see light and heavy areas. You can see the picture to the left is heavy spots, which are red. The corners are usually the blend areas. Those are troublesome spots. The bright green is kind of looking at the paint while it's wet, which in the real world you can't do that. You can use film thickness gauges, but you can't really see across the whole part where the spots may be light or may be heavy. So in this case, two similar parts. The one on the left might have been before training or when they first started using the system. The part to the right, which is more consistent, doesn't have those heavy or those red areas, that would be the part that then would be had sprayed a little bit more efficiently. And then lastly, some of the benefits of training. I always tell somebody it's, if you don't believe in training individuals, it's a tough sell for me to continue the conversation. So what training does is if you have a trained workforce, you get everybody on the same page. You're providing the same message to those employees. And you may have those who are very good painters. You may have those who are not so good at painters or less experienced. And so what training does is it standardizes the process. It doesn't rely on on-the-job training, which is what most people typically do. On-the-job training has to occur, but if that's your sole source of training, my opinion is always be careful of that, because who is delivering that message? And it may be an individual who's doing a great job and got years experience, or it may be someone who's not as experienced and maybe the wrong message is being conveyed. And we've done we've been forced into it on a lot of our government contracts to provide a return on investment, to show our work, so to speak. And so we have data to back that up. And typically you can, with training and putting some time and effort into it, achieve potential 12 to 20% return on investment. Again, there's a lot of factors that go into that, but that would just be kind of the average of what we're seeing. And then you see there 89%, we survey students. I know Caleb is surveying me when I'm done with this and so forth, and tracking information. So 89% said they rated virtual paint as improving their spray technique, which I think is fantastic. And then also one last thing too, we were just at a place last week in Pennsylvania doing a training class, and one of the things that's hard to quantify sometimes is the painter's attitudes. You see it on a daily basis, but it's hard to capture that, other than maybe painters are disgruntled sometimes or complaining. But after the training, the feedback we got was the painters' attitudes greatly improved. Now, we hope that selfishly continues on and their attitudes stay good. You know, you may see some regression over time, but we have noticed investing in training, not just using the virtual paint here, but investing in training and showing them that you care about them a little bit has seemed to go a long way. Okay, so with that, I apologize, we're about out of time, but I'm able to stay on and answer any questions that you may have.
Yeah, thanks, Chris. And so what I want to do real quickly, we've got one question and we'll get to in just a second. If you have any other questions for Chris, please send those in the chat box, and we'll and stick around. We'll get those answered. But I did want to quickly go back over to our actually, let me take presenting capabilities. Go back over to our end of the webinar survey. So pull your phones back out if you don't mind. We're going to go back over to Mentimeter, and yeah, so same three questions we asked before. Just tell sort of, as a result of this webinar, I feel more knowledgeable about the following. So if that statement is true about those three topics, you're going to go closer to, you strongly agree is a 5, and then if you strongly disagree, that's going to be a 1. But so we hope that all the information that was given, I know there was a lot of it, but I feel like even though I'm not in the world of paint spraying, I understand it quite a bit better because of this presentation. So, Chris, thank you. I know everybody's got busy schedules, so I really do appreciate you taking the time to help us out with our pollution prevention webinar series. And did want to let everyone know that we will be, this webinar is recorded, so the recording will be put on our YouTube channel and housed on our pollution prevention webpage, and it will also be sent out to all of everyone that registered for this webinar. So yeah, take your time. We'd love to have your input on what you learned and if you learned from this webinar. So I'm going to stop sharing here. I'm going to go ahead and ask. We still just have one question, Chris, if you don't mind.
Okay, sure.
It says, can the negative air pulling overspray to the filter media, and then it says in parentheses, whatever type, be a variable speed so as to adjust or affect transfer efficiency?
Yeah, so if I'm understanding it correctly, it can. The airflow in the booth for sure can impact coating droplets as they leave the spray gun, and can steer them towards the part or away from the part. So the velocity of the airflow in the booth absolutely can impact your efficiency.
Okay. And, just so everyone, recapping, we will have a second part to this, really hitting on the energy efficiency aspect and energy reduction when it comes to paint spraying. That's going to be at the end of July, so be on the lookout. If you registered for this, I'll send if you're a part of this webinar, you'll get an email with the registration for that. Chris, just wanted to thank you again, and you've got his contact information. So if you're eating dinner tonight, you're like, man, I wish I would have asked this question. There's his email, there's his phone number. I'm sure he'd be happy to answer any questions that you might have. And with that, we are finished. So thanks everyone for joining, and look forward to hopefully seeing some new efficiencies in your paint spraying operations.